Thank you. So since I'm the only one with Andy standing like in between you and barbecue, I've actually bribed the chef to delay the barbecue. Sorry, so I tried to keep it short and really try to inspire you and make it a bit more interesting in telling the story. So I'm basically giving some theoretical background, telling the story of what cloud native is and why it's important, and then Andy will actually go a bit into detail and tell you how to work with applications, deploy applications on Kubernetes. Okay, so agenda and motivation. So first of all, why are we doing this? What does it mean? What is the technology disruption that containers and cloud native bring? So then look into what containers are. Who actually knows or has used containers?
The transport?
Software containers, sorry. Who has actually developed an application and deployed it in a container? Okay. Who knows what Kubernetes is? Okay, very good. Okay, so we go to Kubernetes containers and then talk about orchestration and scheduling, for which Kubernetes is a solution. Then very briefly from like the concept from application from machine-centric to application-centric to cloud native. What we're doing with cloud native at SAP and on Project Garden. So I'm a developer, architect at SAP for like 15 years. And I'm working actually for the Project Gardener, so I'm actually one of the persons who initiated that. I'm very enthusiastic about it, and I hope I can also bring the message around when I show the demo and talk about the project. So connecting those dots, we see as Kubernetes. Like a year ago or 1.5 years ago, it wasn't clear what orchestration would bring, whether that would be like Docker Swarm or Mesos, but since like beginning of last year, it's pretty clear that it is Kubernetes. And Gardener is actually our answer, our project on Kubernetes. Okay, so let's start with the disruption. So personally, I have actually started my career on the left side. So I was actually a mainframe operator, IBM mainframe, running SAP R2. So I'm one of the few employees that actually have seen that R2. But that's not even here. So where did it come from? So we're coming from like 3-tier architectures, and our audience were like our company, like 10,000 users, maybe 100,000 users, but those systems really had trouble scaling more. So as the 2000s went on, we went more into modularization, virtualization started and actually changed everything. So we saw like in that time AWS growing, and today we're hardly deploying software on bare metal, so it's mostly virtualized. Okay, but the world today is actually different. So it's not corporate IT anymore, it's not 100,000 users. It's millions of users, it's millions of IoT devices that hammer your system. So that 3-tier probably isn't quite suitable to kind of deal with that kind of thing. Okay, so what are we doing? We are like componentizing, splitting our applications into microservices. And what we have there is certain types of applications. So on the one hand side, we have scalable, stateless apps. So when you see, for example, Cloud Foundry fits exactly into that. Since they're stateless, they are like easy to scale. You can just add another instances to work with monolith. What's also coming up is like serverless or functions. So basically the idea is that you just don't buy like Cloud Foundry spaces or virtual machines. But like when you have workload, then basically a function is called. And that's it, and you pay basically for the usage. So if there's no usage, you don't pay. If there's lots of usage, you pay. but you only pay for that is actually used. That's also like if there's no usage at night, you pay nothing. If there's lots of usage per day, also your provider can provide those resources, so also answers get encrypted. So imagine that with the old model, you buy hardware, and you need to buy all the hardware for your peak load. And that's basically idle here in the tenant. Okay, so we have stateless applications, but we need state. And for example, distributed state, I mean, normal databases work, but distributed databases, like if data centers goes down or if there's trouble. So there's Vora, Cassandra as examples. And we need some kind of service mesh management. So if we have lots of microservices, it's kind of a zoo that you can't keep under control. Like servers are failing, and that they're failing in a way that they basically hang also. So for your users, that might be quite bad experience. Like, okay, so you have a web page, you like show the temperature, and the temperature service just blocks. And like after 5 minutes, you tell the user 503, and you don't show your page, you don't show your commercials on the page, and that would be big loss. It would be much better if like after 20 milliseconds, the service would say, ah, doesn't work, so I don't show the temperature, but I show everything else. So an example for that is Istio, that is currently making a lot of noise, a lot of interest in the community, to basically provide just that, like manage the microservices, scale up, scale down, do the circuit breaker, and has full control on that. And that is what we, or what not just we, but what the world commonly calls cloud native. And with that comes containerization. So that kind of concept is hard to do without containerization. And here I want to just mention one point, which is the DevOps to NoOps. So the world today is still going into DevOps. We really want to sleep at night. So we really want to go into NoOps. And if we look at Kubernetes actually gives us a lot of hooks to achieve NoOps. So in Kubernetes, it's a system that constantly adjusts itself. You have active components looking for the health of the system and trying to fix them. So we really hope that we can get from DevOps to a NoOps approach. Okay, so coming to containers, what are containers? How do they work? Container basically is an operating system process. So like sometimes it sounds magic, but it's just a process. And the process has been given some CPU share that is controllable. It's given some memory. It has some executables, it has some libraries. It has an environment. So it really, for the process, it looks like it's running on a normal machine. Then what is injected is some configuration. So if you want to deploy a container in different regions for different customers, you need different configuration, you need different credential, you need different like connect parameters for your database or microservices. The same with secrets. Yeah, so you don't want to hard code your secrets in the container, but you want to put them or inject them when you start the container. And your container might need storage. Like if it's a stateless application, of course not. If you want to run a database. Okay, so in Linux, the concepts that are used to containerize are actually in part almost 20 years old. And they were more or less finished, let's say a couple 2013. And then really Docker came out and really made that concept usable. So I'm doing a Kubernetes training. And initially I show how to do that with like operating system mechanism. And that is very difficult and very hard. And Docker really kind of made that simple by just saying, okay, I have a container, run it, and you don't need to care about all that kind of stuff. Okay, so since that is an operating system process, it can also use all the resources, like GPUs, especially, and we see usage also of GPUs at the moment. Okay, so but the container is not just like the runtime mechanism, but also a vehicle for deploying or delivering software. So the idea is that also Docker pioneered is to have a container registry, and we have an operating system. The difference here to like the approach today, or the common approach, is that operating system is tiny. So there is nothing on it, because all the software that you want to put on it, you get from a registry and install on the machine. Yeah, so you basically download the container, it's getting instantiated, it's getting injected the configuration and the secrets. If you need storage, the storage is attached, and the process is started. Okay, so what are the like advantages? So the OS is tiny, so we're looking at like 200 megabytes, 300 megabytes. Ubuntu just came out with minimal OS with 50 megabytes. I'm not sure that is true. But it's not like the gigabyte or more that you get with enterprise Linux distributions. No DLL help. That's actually very important, because you package everything that you need into your container. So if your container needs Python 2, it packages Python 2.7 or so. If you have another container running on the same host that needs Python 3, it packages Python 3. It's like not when you install it on the host, and then unfortunately your program took the wrong Python version and it just doesn't work. That will not happen. It's reproducible, so you can do that 100 times. Also, if you scale out, if you add more nodes, you just download the container, start it, done. So it's very simple compared to like setting up yet another machine and then provisioning it. So we provision new nodes in a couple of like 2 or 3 minutes, and then software starts to work. Okay, so that were containers. Also was like looking at the traditional Docker environment. That was running on a single host. So what do you do? I mean, single host, you get an email from AWS saying, your instance may be unresponsive already, and there's some hardware degradation. So what we need is orchestration at scale. So we have our containers, we have our data centers, and what we basically want to say is we want to orchestrate and schedule them. And we want to do that in a declarative way. We want to say that container application, please run it in like a US data center or in the US data center, and that workload please run in the EU data center. Or we could say, yeah, run it in the EU data center, but only if there's space available, otherwise run it in the US data center. But we do that in a declarative way. We don't say, yeah, do that, but we say, yeah, this is what we want, do it for me. And that will take care of like injecting the configuration into the containers, attaching volumes, and it also checks like if you need a volume, that this volume is actually available in the region and in the zone that you want to start it. If a node goes down, it tries to reschedule that container on a different host. So Kubernetes is actually based on like 15 years of experience at Google. So if you use Google, or if you used Google like 10 years ago, you had actually used the containerized application. So Google donated Kubernetes to the CNCF, the Cloud Native Computing Foundation, which is kind of the place where the industry gathers for cloud native. Okay, so why is Kubernetes more? So we often see that kind of demarcations, that picture of like YaaS and PaaS and SaaS. And Cloud Foundry is clearly a PaaS. So where does Kubernetes fit? So if you go to our IT department, they would say it's YaaS. And I mean, pretty much, yeah, you can almost do everything that it is that they will move into containers. But Kubernetes is actually cross. So you can't just say, oh, that's a YaaS. So with Kubernetes, you can provide like function as a service, you can provide PaaS. So we have a project looking at running Cloud Foundry in Kubernetes. There is Knative from Google, which is an initiative for PaaS running on Kubernetes. It's actually, we've run HANA, so we have run HANA in Kubernetes. So it's really the whole stack. So it's really not appropriate to just put it into one layer and say, ah, that's it, and so we put it in a box. Okay, so just talking quickly about machine-centric to application-centric. So how we were doing that in the last, let's say, 10, 15 years was, okay, we get a VM, we install an operating system, or we get that operating system already, and then we install our software, like all in an iterative way. And once we've installed the software, we update it, we update the operating system, we update the software. This is also what we see quite often at SAP. Yeah, this is the way we do, and with containers, that really changes. And it's really a big shift. So you basically have an operating system that is scaled out, so you can easily add other nodes. And then you say declaratively, hey, that is the applications, or these are the applications I want. And you throw them at the system. And this is actually something that Andy is going to show how to do that. And then the system basically looks for itself how to best distribute that throughout the system. Like that the best like memory is utilized and CPU is utilized. So we had an evangelist from Google talking at our DCOM, and he showed that with stateless. Yeah, so like how to best put all the pieces so you optimally use your CPU and optimally use your memory. And this is what this is about. Also in that space, you don't update anymore. So you don't update the operating system, and you don't update the application. So when you update, really, okay, you delete the node and start a new node. Yeah, you drain the node, delete the node, start a new node. We have to do that quite often at the moment because of all those meltdown and foreshadow. That's actually quite easy. Also for the containers, like you don't update the software in your containers. No, you just stop them and start up a new version of the container using the new version of the application. So very different thinking, very big shift. Okay, so a few words on Cloud Native at SAP. So we joined the Cloud Native Computing Foundation roughly a year ago, and this is actually where the industry centers on Cloud Native. So with Kubernetes, that is becoming the de facto industry standard. We are contributing to Kubernetes, and with Project Gardener, we hope to set a standard for Kubernetes also in the CNCF. Looking at our team has grown from 4 to 30 people. And being out there, working with the CNCF has really helped to attract talent. Okay, so what are some of the noteworthy projects and organizations? So there's Cloud Foundry, the Eclipse Foundation, the CNCF, and the Open API initiative. And some of the products are like the SAP JVM or OpenDB. Oops. Excuse me. And with Project Gardener, I think we've stepped up the level. Our colleagues have Kyma. Okay, so how would that influence SAP Cloud Platform on Kubernetes? So I can't say so much because there will be some announcement at TechEd. What we really see is that basically we operate our SAP Cloud Platform in our own data center or on those cloud providers. Was like more to be added, like Alibaba in China. The foundation of what we will do will be Kubernetes. So everything that we run on top, whether it's going to be like ABAP systems or HANA or Cloud Foundry, will run on top of Kubernetes. Okay, so Project Gardener. So like 1.5 years ago, we were looking into, okay, how can we provide Kubernetes? How can we provide a lot of Kubernetes? So we're talking 1,000 or even 10,000 Kubernetes clusters that we need to operate. How can we provide them in a secure way? Was like day 2 operations, like for example, doing the updates. There are like new Kubernetes versions every week. Doing the updates for the operating system, doing the no-ops approach. How can we do that? And we figured out there was nothing on the market. So there was basically Google had a solution. All the other cloud providers had no solution. There were developer tools that we took, but they were really hard to use. I mean, we're looking for like not so technical people being able to write and run containerized applications. And looking at those descriptions, that was really hard. So what we've done with Gardener is actually a multi-cloud Kubernetes solution, where you basically select, okay, what cloud provider do I want to run Kubernetes on, and then they run homogeneously on those cloud providers, so they look and feel the same, no matter whether you run on like Azure, or AWS, or so at that time, we looked and there was nothing. And we're quite sure, okay, that is very attractive. So we know that other companies, we have that numbers from other companies as well. They say, yeah, we need 10,000 clusters, we need multi-cloud. Heard that a couple of times. And I was pretty sure that if we don't open source it, then somebody else will, and we kind of have to adopt. And this time we want to be in the driver's seat. And this actually looks quite good. So I just want to show quickly how easy it is to create a cluster. So this is our dashboard. Let's see whether I have to log on again. No. So this is basically our development cluster. So I just say new cluster. I give it a name. I select the cloud provider. So we're actually working on a couple more. So the next one will be Alibaba. So let's stick with AWS. Select the region that we have configured, the Kubernetes version, like the zone. And then we can say, okay, let's select worker nodes. Like, what do we want? So we can say, those are standard worker nodes, and I want 2. And maximum 9. That means if the scheduler figures out I can't schedule a port because like Tetris, all the lines are full, I add another node. And that is automatically, and you will see a delay of like 2 minutes or so. And then you have another node, you scale out. If I have GPU workloads, I can add GPU nodes. So I have some types here. I think the P types are GPU. So if I have certain GPU workloads, I can also declaratively say that container needs to run on a node with a GPU enabled. Okay, so since those ones are expensive, I remove them. They're going to be add-ons. So at the moment that's quite boring. But we're looking at add-ons, like what I said, Istio or Knative or Kyma, that basically you get them on the cluster. And we do maintenance, we have to do maintenance, like foreshadow 2 weeks ago, like new Kubernetes versions, and we just say, hey, this is kind of the optimal, or what is the optimal update window. Okay, so where are we with that project? It's actually, you know, in big companies, like sometimes departments mistrust each other. And so we had another department saying, yeah, no, we go with that native solution of the cloud provider. Like they also have Kubernetes as a service solution, and they said, I know, don't go with you. And they came back this week and basically said, that solution is so crappy, and we looked at yours, and yours runs much better on that cloud system provider than the native solution. So we're really, really excited about it. And it's all open source, so everything I've just shown here is open source. And it's the only open solution that we have or that is out there at the moment. So like all the other providers, even Google, are proprietary. And I invite you to have a look at it. If you're interested in it, contribute. We're looking for contributions. And yeah, I think it's a really cool project. Just a few words. We've basically built Gardener on Kubernetes. So Gardener is really a Kubernetes resource. And so basically that is a resource that we throw at Gardener and say, hey, create a cluster that we call shoot. And in like under the hood on what I've shown is that for example, those are the worker nodes here that are created. We can do a lot more here because building UIs is kind of difficult. That we need to like put in the UI later. But this is really like we go through the UI. We have a command line. It's going to be in the SAP Cloud Platform cockpit. And some custom. And what we really want to do is for SAP Cloud Platform provide a homogeneous Kubernetes solution that looks and feels the same on all the different cloud providers, no matter where it is running. Okay, so just a short mention of the mission statement. So manage, maintain, and operate many clusters. And, I mean, we're running roughly like 1,000 clusters at the moment. We expect like 10,000 clusters plus sometime next year or the year after. They should be conformed, so they are fully conformed. So when you go to the CNCF webpage, we are listed as one of the conforming Kubernetes distributions, and actually I think also the one with the most GitHub stars already. Okay, so it's basically like written like with Kubernetes in mind. So it's like we use a full set of Kubernetes components to actually write it. I'd love to talk about that for like another hour, but yeah, I see the barbecues coming. Okay, so I hope I could inspire you a bit. Have a look at containers. We believe that it will change how you develop and deploy software in the next 2 to 3 years. So we believe it's very important, and I mean, looking forward, I don't think that software companies will deliver installers to their customers in a couple of years. So from my point of view, that will be all containerized. Get familiar with Kubernetes, play with Gardener, especially if you want to do multi-cloud, and connect your applications with dots with cloud native. Yeah, so we're also still looking for developers. It's a really exciting environment, and I hope I could inspire you a little bit. And I will hand over to Andy to show a concrete example on, like, once we have created a cluster, how to go on from